Hello, PreCalc. We have been studying the ellipse, and this is the March 7th, Monday edition. And we will just add a little bit more to our ellipse journey. It seems like already we have seen this idea that when the vertex is at 0, 0, that the standard equation is x squared over a squared plus y squared over b squared equals 1, or x squared over b squared plus y squared over a squared equals 1. And in both cases, a is greater than b, so we can tell which is horizontal and which is vertical. On this one, the larger value is under the x term, so it is horizontal. And here, the larger value is under the y squared term, so it's vertical. So that's old news. Then, if the vertex moves to HK, Hector and Kyle come out to play. And H is paired with the opposite sign with the x value, and K is paired with the opposite sign with the y value. So it looks like that. So it can look like that, where A is the larger term, A squared is larger than B squared. So this is horizontal. And over here is the other choice. When the larger term is under the y term again, it is a vertical. All right, I believe you've seen all that. If not, pause it and get it down. I wanted to establish another idea before too long here, and that is here, draw an ellipse with the two foci. And you'll recall the foci are what we had attached our string to, and I was wondering if you can figure out, like if I put it in this position, any point on the ellipse, connect it to the two foci, this is a given length. So now I'm going to move it over to here. And then this gets longer and this gets, well, whatever. They're going to be the same length. The two sums of the two. Kind of gets confusing when I don't draw it well. Alright, so then say I put a point here, then this plus this equals a certain length, and it's the same as it was when I had the point here, because the string is not changed. Alright, so that's if I have a true elliptical shape here. Mine looks kind of strange, but let's see if I can cut it off there a little, look more elliptical. Well, the point I'm interested in is when the point on the circle is right here, in line with the foci. So, if I can sketch this, this one will start here and go here, and this one will come from here and go there. So this will be right on top of one another, but I kind of drew it so you can see the overlap easily. So I was wondering if I picked this part out that's double, this part right here, and I moved it over here. So I'm taking this part, so I have another color somewhere. This part right here, so it's showing up with a different color. It's supposed to be blue. If I pick that blue part, cut it off, and put it over here, can you tell me the length of the string? I've just rearranged it so you can more easily tell. So this part is gone now from here, the blue, and is placed over here. Do you see that you can easily see the length of the string in terms of A or B? It is, remember, when we had the center, from here to here was A. So the string in its total length from here to here is 2A. So I hope that makes sense. Anyway, the string is 2A long, so I am going to put the string, here's the center, and here's the foci. Now I'm going to put the string here, right there. and here. So these are equidistant here, and I'm putting it at the vertice where the minor axis hits the ellipse. So what is this value? Remember, the whole string is 2a. Do you see that the distance from one focus to this vertice on the minor axis is half of 2a? 1a plus 1a. So here's a. We already know this amount from our previous study. That's b. So we're going to call, we called from here to here a as well, but it's the same as from here to here. It doesn't look like it on my sketch, but on a really accurately drawn ellipse it is. I'm going to call the distance from the foci to the center c. It does form a right triangle, and the relationship a squared being the hypotenuse equals b squared plus c squared. So observe that where c is the distance from the center to the foci. It's related to the foci. Alright, let us then keep that under our hats, and it's going to help us with our problem. Alright, the problem that you need to learn today is how to graph an ellipse. So here's it in general form. X squared plus 4y squared plus 6x minus 8y plus 9 equals 0. So the command is graph. Alright, when we're asked to graph an ellipse, you can tell it's an ellipse if it has an x squared and a y squared term, and they're both plus or they're both minus. So this is an ellipse. So first of all, you want to gather your x terms in one spot. X squared plus 6x, then leave a space, and then gather your y terms and leave a space and move your constant to the other side. Alright, now we're going to complete the square in two spots, and we reminded ourselves how to complete the square. It has something to do with this term. Take this term, take half of it, divide it in two, or multiply by 1/2, whichever method you can retain. 6 divided by 2 is 3, and square it, 9. So to complete the square, I add a 9 here, and if I add a 9 on this side, I have to add a 9 on this side. A precaution here, we cannot complete the square when the number in front of the squared term is not a 1. So that is not a 1, it's a 4. So before I can complete the square there, I have to factor out the 4, which is nice because the 8 cooperates. Can be fractional, we can handle it, but not this time. So this turned out to be 0 now. So now that I've taken out the 4, factored out the 4, I can complete the square by taking half of this and squaring it. Half of minus 2 is minus 1, minus 1 squared is 1. So you might be tempted to add a 1 to this side because I added a 1 there. But this is only masquerading as a 1. It's really a what? It's really a 4. So I must make note of that and add a 4 to the other side. Alright, let's complete the square. That means I'm going to write these 3 terms as 2 terms squared. So it's going to be x plus 3 times x plus 3 will give me that. Then we have a 4 outside the parentheses, and what times itself, what 2 terms times itself will give you, squared will give you these 3 terms. It's going to be y minus 1, quantity squared. And over here we end up with a 4. And if you recall, on the ellipse, this has to be a 1, so we can divide every term by 4 and create the 1 that we need. So we have x plus 3 quantity squared over 4 plus these 4's reduced to a 1 and equals 1. All right, now we're ready to graph. We can look quickly and see that Hector and Kyle are, the new center is -3 plus 1. That's the center. And A is the value, this is A squared, so A is 2, B is 1, so this is the larger, so it is a horizontal. So putting that together, we can get a lot of the story. So I'm going to sketch the center, -3, 1, right there. And I know from the center I'm going to go out 2 in both directions. So 1, 2, well that'll be one vertice, and 1, 2, that'll be another vertice. Since I was at -3, 1 and went back 2, that took me to -5, 1 for this vertice. And here I went from -3 back to -1, 1 for this vertice. And now I'm going to go up and down our B value. So from here, which is -3, 1, I'm going to go up 1 and down 1. All right, this one is -3 and 1, so now it's going to be -3 and 2, the value of that vertice. And this one is down 1, so it's -3 and 0. All right, I can sketch this, and all I need is, I do have the sketch, but I do also want you to be able to find the foci. So I'll put them in somewhere here and here. So I'll call this the foci on the left, and this the foci on the right. So foci left is going to be on this line, which is at 1. So I'll put that value in. But I need to know how far this is. So I knew the relationship is like this. This is A, this is B, and this is C. So once I find C, I'll be able to identify the foci. I know A and B, so working over here, I have A squared equals B squared plus C squared. And A is 2, B is 1, and that will help me find C. So C is going to be the square root of, do I have that wrong? I believe I do. C squared plus B squared equals A squared. That's right, never mind. So this is going to be square root of 3. So how do I get the name of this focus on the left? Well, I've started in from the center, and the center was -3, 1, and I went back the square root of 3. So I'm just going to write that as 1, because that is, I'm sorry, -3. And I went back the square root of 3 from there. So starting here, the x value was -3, and I went back another square root of 3. So I'm going to give myself a little more room. -3 minus the square root of 3, and then 1. So what would be the foci on the right? So it's going to be at 1 again, but the value here is still going to have that same value of C from starting from the center and moving C to the right. So I was at -3, so I'm going to go to the right a square root of 3. So that will lead me to -3 plus square root of 3. And that will be the foci on the right. Alright, so we were able to identify the center, the vertices, and the foci and sketch it, and we are extremely happy about that. Alright, that's all for tonight. I'm going to have